This equation is the baseline calculation for AI share of voice, but the math breaks down with biased inputs. If you run 100 prompts explicitly including your brand name, you'll calculate a near-perfect score. That score ignores the physical constraints of AI engines. Traditional search engine pages could hold 10 organic links and multiple ads. AI-generated answers only have room for 3 to 5 entity mentions. Often, just one gets the primary recommendation. Because of this limitation, AI search operates as a zero-sum environment. When a competitor gains visibility in an output, they actively displace you. Generating a high metric by using brand-heavy queries measures your team's ability to simulate visibility, not your actual presence in a restricted market. To capture accurate data, you have to treat the prompt set as a highly sensitive mechanical survey instrument. The questions you feed into the model dictate the validity of the data you extract. A common point of failure occurs when teams dump legacy short-tail keywords into their LLM trackers. Running broad phrases like content marketing or SEO will yield 0 brand mentions in the outputs. Language models do not process broad terms the same way search engines do. They prioritize highly personalized, long-tail queries that define specific constraints and problem-solution scenarios. Extracting valid signal requires a multi-layered data ingestion protocol. You need a system that filters unstructured customer language and turns it into a rigorous testing array. Without calibrating that instrument, tracking probabilistic AI outputs produces noise instead of actionable intelligence. Constructing a rigorous tracking architecture requires a 3-layered data ingestion protocol. The first layer is terrain calibration. This step strictly defines the specific subcategories and feature sets where your product actually competes. If you build software for enterprise localization, feeding generic translation queries into your tracking array mathematically dilutes your core measurement. You must ruthlessly discard any prompt that falls outside your strict terrain parameters. Relevancy determines validity. Defining these boundaries also dictates the competitive entities you track. You only map the brands that occupy those exact same parameters. Processing out-of-bounds queries wastes computational bandwidth and obscures the actual commercial battleground where your buyers make decisions. The second layer extracts ground truth data from your buyers. This requires mining internal data nodes from pre-awareness channels. You pull directly from unedited sales transcripts, technical support tickets, and raw CRM logs. You pair this with external data nodes to capture the questions asked before prospects enter your funnel. You target technical subreddits, Discord architectures, and niche industry forums. A standard keyword like best CRM does not reflect this data. A high-intent constraint query looks like, has anyone used X versus Y for running content audits? To engineer the instrument, you translate raw complaints and comparisons into trackable LLM prompts. The intent transfers, while the format adapts to AI architecture. Injecting this ground truth forces your tracking array to measure the precise questions buyers execute, stripping away idealized marketing wish lists. The final layer is search triangulation. You use this step strictly to expose the structural blind spots your first-party data missed. You execute query fanouts using autocomplete and related search data. This maps adjacent queries branching off your core voice of customer constraints. Once the raw data is gathered, you run an architectural compression phase. You reduce thousands of potential prompts down to a highly concentrated testing array of 1 to 200 inputs. You categorize this final array by product feature entry points. Grouping prompts by specific capabilities lets you gauge brand visibility against industry competitors in distinct subcategories. The secondary segmentation divides the array vertically. You tag each prompt by its exact funnel stage and target buyer persona, separating CTO constraints from marketing director constraints. A triangulated, fiercely segmented prompt set filters the probabilistic variance of AI responses into a high-confidence data stream. With the instrument built, you extract 2 specific output metrics. Entity-based share of voice counts the exact number of times the model recommends your brand as a named solution. Citation-based share of voice tracks how often the model invisibly references your digital infrastructure as a source material for its output. Entity mentions dictate direct pipeline conversion. Citations act as a leading indicator, dictating your underlying influence on the algorithm's conversation. This matrix categorizes the software required to extract that signal. AI responses are non-deterministic, meaning the same prompt produces different results over time. Extracting clean data requires automated, repeated software sampling. Scrunch deploys effectively for technical crawling diagnostics. It isolates visibility by buyer persona and identifies whether low visibility is a content failure or a technical crawler block. Profound deploys for heavy data extraction. It processes multi-engine tracking across a massive historical footprint, serving enterprise architectures with high budgets. Peec AI handles high-velocity daily sampling. It provides clean, frictionless measurement loops without imposing per-seat operational bottlenecks on the team. Attempting manual measurement across these models introduces fatal human variance. Automated, high-frequency sampling is an absolute prerequisite for maintaining data integrity. Analyzing these outputs requires stripping away static benchmark percentages. A static visibility number holds no strategic value when separated from your specific business model and prompt set. The absolute numbers only indicate thresholds. Holding 20% of the share of voice indicates your brand exists in the data. Breaking past 80% signals you are the category default. This graph tracks velocity. The static metric is secondary to the market share you gain or lose over time. You evaluate this velocity against a tight cohort of direct competitors, ignoring the broader market noise. A snapshot of current visibility is useless. Measuring your relative trajectory over time is the only empirical method to prove your strategy is capturing market share relative to your competitors. Your instrument has a rapid decay rate. Buyer language constantly shifts, new competitors emerge, and foundation models aggressively update their training data. Engineering teams must execute a strict quarterly recalibration of the prompt set. Relying on a stale array means you are actively measuring a market that no longer exists. The AI recommendation surface area is narrow. Brands securing early dominance benefit from a retrieval feedback loop, raising the barrier for lagging competitors. The metric forces a decision. You are either engineering your digital architecture for the zero-sum reality of AI evaluation, or you are still optimizing for a legacy search environment.